Hello, everyone. Welcome to Awkward Devs 115. I'll post the agenda in the chat here. Oh, sorry, made the chat go away. Okay. Cool. And we are live. Everything seems good with the live stream. Great. So first thing I had on the agenda was just basically to get an update on Calaveras. I know Marius kind of spammed it earlier this week. I don't think he's on the call. But yeah, I don't know if another team had just like an update about. I know Besu and Nethermind. There was some things found when Marius did his test. I don't know if you want to walk through that.
Yeah, I think we were generating blocks that were too large, and so they were being rejected. But I think everything is working now. We should be fine.
So from Nethermind side, I know there are some issues that we stopped producing blocks from time to time, but I'm actually debugging this today, and I think I found a solution. So I will restart Calaveras validator after I'm done.
Awesome. And I think those were kind of the two only issues. It seemed like anyways, I didn't find anything else. I don't know if anyone had any other, any other things to share about Calaveras. Okay. So the next one, this is actually quite a big one, is over the past like week or two, there's been a lot of conversations about JSON-RPC and 1559. And basically, it seems like there's 3 open questions left that I was hoping we could kind of resolve on this call. The first one, and this was Martin's, so he's not here yet. The first one was ETH call. We can maybe skip that one and see if Martin comes in. The second one was probably the simplest. So basically the idea of adding the effective gas price to the ETH get transaction receipt. Light client, you had a PR open for that already. It seemed like everyone was roughly in favor of it, but we just wanted to check here to see if there was any objections or if people all thought this was a good idea. And let me post kind of the PR here. But yeah, this would just make it easier for projects who are dependent on the effective gas price that want to show it to their users and whatnot to fetch it, so they wouldn't have to manually calculate it. It would just be in the transaction receipt.
So I think there was a discussion a while ago, either on Discord or maybe in some other channel, where people were saying, hey, maybe we just have tx.gas price be set to the effective gas price. And so when you do ETH get transaction, it would return the effective gas price for all transactions, because the gas price is the effective gas price today. And then for 1559 transactions, that would be overloaded to be the effective gas price. So I don't know. I think that might actually be how Geth is currently implementing it. And I don't know if people want to continue having that behavior, or if going with this PR also means to revert that and only have gas price for non-1559 transactions. I know some of the people in this PR specifically want to do the latter, where gas price is not in the transaction object and it's only in the receipt. And their arguments are that the effective gas price is this computed property, and so computed properties generally shouldn't live in the transaction return value. They should be things that are sent by the receipt RPC, but that's just their argument.
Does anyone from the other client teams have thoughts on that, or at least like how it's implemented now in your client?
think that second one sounds more intuitive to me as a consumer of the API, since setting as the gas price seems to imply that, yeah, it's a field that was set in the transaction. I kind of like it being separate, but that's not a strongly held opinion.
Yeah, Nethermind, any thoughts?
Not really, so I don't have any opinion on this.
Okay. And yeah, do you know? So right now, what does transaction.gas price do in Besu and Nethermind? Does it also just return the effective gas price? Like, I guess I don't know. Yeah.
I think we don't do either yet. I don't think we return the effective gas price as the gas price, nor do we have the effective gas price in the receipt yet. Just waiting on clarity for that.
Yeah, we have a PR for that, but we're waiting.
Okay. And like client, you said Geth basically already does this thing where it returns the effective gas price in the transaction.gas price. So we would need to revert that in Geth and then move it to the receipt, right?
I believe that is, but if anyone else on the Geth team is here that can better speak to it, jump in.
Yeah, unfortunately, I didn't really follow this particular issue, so yeah, I can't really add anything.
Okay. Yeah, it seems like no one kind of has a strong opinion on it. Yeah, like client, since you opened it, do you have a preference for, and you did a lot of the work on the Geth PR as well, do you have a preference for moving it? Like, I guess, would you be, if we just like merge in your PR, are you okay doing the change in Geth if it needs to happen so that it
Sure.
Okay.
Yeah, that's fine. I think
Okay.
like I don't, again, I also don't have a strong preference, but I think that the people who wanted it in the receipts brought their arguments, and so, there's no one really opposing it at the point
Okay.
at this moment.
Okay, great. So yeah, I'll merge the PR in today and we can use that as a reference so that, the effective gas price goes in the receipt. And if any implementation already has it in like the tx.gas price, then we can just revert that. Cool. That was the first one. Oh, I see Martin is just joining, so we can probably do the ETH call thing. Hi, Martin.
Hi, sorry I'm late.
Oh, no worries. Yeah, we were just talking about JSON-RPC, and you had posted this comment in Awkward Devs about ETH call, trying to figure out how does it deal with the base fee and the gas price. Yeah, do you maybe just want to give like a quick background about that? Like, yeah.
Yes. So the background about it is that for ETH call, Geth and Parity back in the day used to handle things differently. Geth would use whatever the account of the node that you made the call on, would use that as the caller, if unless otherwise specified, and that was a pretty arbitrary choice. Parity used the zero address as the sender, and Geth switched over to that as well. And the problem is that the zero address didn't always have funds. And as a solution for that, we use the zero gas price. So we can do the ETH call, you can see what happens, and it works. So we can specify any gas limits you want because gas doesn't cost anything. And the problem with when we do ETH call on 1559 is that it has to cost something because there's a base fee. And if we use the base fee, we have to charge the whatever the base fee is. So if you use zero address, then we again run into this problem that there might not be any funds. And I am not the best person to speak of how we eventually fixed it, but it seems like Peter is not on the call. He eventually fixed it and merged into Gap. I think what he did, if I understood correctly, is that unless you specify gas, he hacked around it a bit. So if you do the operation, the opcode base fee, you'll get the correct one. But charging wise, it will not charge.
Recording in progress.
Yeah, I can't detail it further than that. There's a PR which was recently merged.
I guess, do other teams have ETH-call implemented yet?
So I'm not exactly sure what we do right now. I can get back to you.
Okay.
Yeah, I would also need to check the details.
Okay. And I saw, I think it was Open Ethereum left a comment on the issue saying they would like to add the optional base fee to the parameter list. Yeah.
Yeah.
Which...
Currently Open Ethereum uses the base fee from the block header that is provided in a parameter list when you call ATH call. There is actually no way to set the base fee to 0. So if I understand correctly, the discussion on the Discord, we want to, for this function ATH call, to work in 2 modes. One mode is to mimic what happens in reality when you apply some transaction on a specific block. And the second mode is to just analyze the contract code, I guess, while assuming that the base fee is 0 and the gas price is 0. So just to omit some of the data that is not needed for that mode. So I think the right way to discuss about it is to first decide what's the actual meaning and the usage of this function. Should we just assume that this function is used by default, that is used to analyze what happens in reality, and then if we want to use it in some other specific way, then we need to provide additional conditions through the parameter list.
Yeah, I posted the link to the PR that Peter wrote on Discord. He basically says there are 2 major use cases that need to be covered, and then he has 6 different tests/cases before and after 1559. It would be interesting to know whenever you guys implement something regarding this, if you guys do the same thing or if you find reason to do something else. If you can just post it somewhere.
Yeah, Peter's PR description there is very good. It feels like
Yeah.
it probably makes sense to use that as like a reference, and if teams have like some disagreement with it, we can deal with it then. But it seems like he's really thought through all the various scenarios. Okay, so I'll link it in the ticket. And yeah, if people have issues or changes they want to make, we can discuss them next time. Cool. And the last JSON-RPC thing was, what was it? Sorry, lost in the tabs.
The gas price or fee history.
Oh, yes. Okay. Yeah, best one for us. So basically, there was another long conversation on the Discord this week about whether we should use ETH max priority fee per gas to return kind of a value for the priority fee in the clients, or whether we should just return raw data and allow wallets to kind of calculate their own priority fee, because it will be much simpler post 1559. Micah had posted a quick comment on the chat, kind of summarizing that, from the last call we had with a bunch of wallet providers, it seems like the fee history approach would be better. I think there was also, like some issues that he and others had raised in the call with wallets, that if we go with like the max priority fee per gas API, it kind of becomes a crutch, and maybe wallets will like never build better estimators. Whereas if we just start with the fee history API, things, it kind of forces people to actually build an estimator on top of that. Zult, I know you had worked on the fee history API. Do you want to maybe take a minute or two to just kind of describe how it works and what data it returns?
Okay. Yeah. So the fee history API is it's this raw data approach, and like I came to like this conclusion that this could be the best solution based on like these long discussions and everything. So I also had an initial suggestion that try to like give like prices as results, and I think Peter was also kind of opposed to it. So what fee history does, it basically just returns. So you can specify like a number of blocks, how many recent blocks you want to retrieve. You can also like specify that you want to. So you can also select a block range, which can even be an order range, or it can go up to the head block, or if the backend node is a minor or a full node that has a pending state, then even the pending state can be accessed. And what it returns for each block is it returns the base fee, it returns the relative like gas used, and so that's just a number between 0 and 1, and it can return multiple percentile samples of minor reward. And by minor reward I mean the effective reward, the effective tip, so what the miner can keep. And so basically the API, in the API call you can specify either one percentile number, which can be 0, in which case it returns the smallest minor reward in a specific block, and in each specific block, and or you can specify, like if you specify 10, then it will return the 10th percentile calculated. And when I say percentile, I mean weighted by actual gas used inside the block. The call even allows specifying multiple percentile values, and then it can take multiple samples from each block, because calculating this is basically 0 overhead, and it can be useful. So yeah, this is the basic idea. And by the way, about the other thing, the max priority fee API, so I can add a little bit to that, and that's basically that I also kind of think that maybe it wouldn't be very good to just drive the wallet developers in a way that so that they just use this single number suggestion, because I don't think that's going to like be a good direction. So the reason we have this thing is that we allow sending transactions where the price fields are not set at all. So Get has this like autofill feature for prices, and if we want to send a 1559 transaction, then we have to just fill in some very dumb default. And maybe what we should do is that we should have this number for the autofill, but maybe not expose it as an API function. So I think this would be maybe the best compromise. And yeah.
Piper, you have your hand up.
Yeah, so I have some concerns with standardizing this type of thing because it requires nodes that serve it to have access to a like decent chunk of kind of like recent history block data. I guess it's not a huge chunk, but I'm thinking about kind of light nodes and light nodes that want to be able to expose JSON-RPC still. And this kind of thing is going to continue to make that more complicated. Whereas this data is servable, if I understand correctly, from, I mean, it's really just aggregated data over the recent history of blocks. So I recognize that it seems more like a convenience API that aggregates that stuff, but by standardizing it, it puts like further barriers to entry in kind of putting an on par JSON-RPC API for light nodes. So anyways, just voicing those concerns.
Would that also be true of the max priority fee API? Because I think you still need to look at the transactions in the block, right?
I'm not familiar enough with this to answer that, but I assume that that might be most recent block as opposed to like significant aggregated data over large recent block ranges. But somebody can correct that for me.
You are kind of correct. So correctly, if we serve with the like currently existing gas price oracle, yes, we need to access a few blocks and we need to like fetch the transactions in order to extract the data. And that's what the old gas price oracle does, and that's what the fee history implementation also does. And well, yeah, it works with the light client. Obviously, if you want to retrieve like a long history, which you are not forced to do, you can just if you just want to operate a wallet, you can probably fetch the last 2, 3, 4, 5, I don't know, blocks, and you can do that with the light client. And yeah, so having an API that's theoretically servable by a light client, and with some parameters, it could be like expensive and take long. Well, that's true for most of our APIs. You can do like large filtering, and you can do a lot of stuff that does work with the light client, and these things do work with the light client without any problem. It's just, yeah, if you retrieve like a 100 block long history, which you just don't need for a wallet, but if you do, then it will take long time. So I think right. It's
you can. I'm totally on board with you in that yes, you can absolutely do this stuff from a light client context. I'm just giving I'll call this just like a -0 small pushback on adding a new standardized JSON-RPC API that is kind of inherently. Maybe the concern here is that it's very much not like O1 operation time that like you said, logs and endpoints like that have parameters that users might pass into them that make it that it could have unreasonable bounds in terms of how many blocks they want to process this stuff for and things like that. And that, the end expectation for users is these things just work, right? Like you say, yeah, give me the average whatever for the last, 100,000 blocks, and the expectation is that it'll return that data. But on some level, it becomes undefined behavior, because what happens if clients start, even not light clients, start dropping old blocks and things like that? Or what happens if they pass in a 10 million block range or things like this?
I think the biggest difference here is that you don't need like a very large number of blocks to build a good estimation. Because 1559 adapts pretty quick. I think it's like every 6 blocks, the base fee doubles. So you can see with like a handful of blocks what type of like regime you're in. And so and that's what you can use and then set your tip.
Maybe something that would make me feel a little bit more like less resistant to this was if the JSON RPC spec had some clear bounds on like expectations for, you know, longer ranges into history or longer ranges of blocks, or even actual upper bounds, say the behavior of this is undefined above this range.
That's a good point. So yeah,
I mean, like, I would
actually,
love to see that for the logging endpoints, to say the behavior of this endpoint is undefined above this number of blocks or whatever. So
yeah, that's a fair point. So the thing is that already, so the fee history spec already allows, optionally allows, giving data about the pending block, which is also obviously something that light clients can do. So that's also specified as some backends might support it, but it's optional, and the caller should be prepared for that it might not work with some backends. And maybe we can just do the same thing with block count, because it's not O1, it's O block count, and we can just say that like supporting this for block counts larger than 5 or 10 is optional and might depend on the backend whether
cool.
it will be reasonable or not.
That'd be great. The other thing that I might ask for here is some way for the node to signal back to the user what is allowed into this endpoint. So whether or not this is some sort of like meta endpoint that we start exposing that displays information that the node can hit and say, how many blocks back am I allowed to go for things like this endpoint or logs or things like that? Because that's the other hard point here, is that even if we make it clear that nodes don't support this, it still doesn't really quite address the issue, because the wallet software still needs to be able to somehow figure out what am I allowed to ask of this endpoint, and just sort of poking it until it stops responding empty probably isn't very good UX.
How about, that's also like,
we don't have to solve this on this call. I just want to like drop these ideas in here because they're kind of like problems that have showed up in past JSON-RPC endpoints.
Yes. Yeah, sorry.
I was just gonna say, quick question: like, how many blocks do light clients typically hold on to? Like, what's like is it like 220, 200?
There's no real number here, but I think 256 has often been just like a sane, like,
okay,
like
but
recent
light
trail of
clients don't
history.
really, sorry. Yeah, so that light clients don't really hold on to blocks by default at all. So in some sense, the answer is 0, but they can like request it, but that costs some bandwidth and time. So yeah, definitely like requesting 200 block history with a light client is too slow. So maybe one thing that we could do about this thing is that the call format already allows like not supplying all the data that the caller has requested, because the answer contains like the first block number of the results, and then the lists of base fees and rewards and everything. So it's totally possible, and we can just specify that the backend can anytime just limit and say that, okay, you have requested 20 blocks because maybe the full nodes will serve it, but the light node only wants to serve 8. So yeah, the answer can just point to a later block as the first block and contain like 8 blocks of results. And I think that could also work, because the coder should be prepared that, okay, now this backend didn't give me so much history, then I have to work with what I have. And
yeah, and that generally makes sense to me. I feel like 8 to 10 blocks is probably sufficient to like get a very good estimation, because you know, if you have like that amount of full blocks, you know, you definitely know that like you're in a massive demand spike, and you'll need to put a big priority fee anyways. So I guess just to take a step back, would all the teams be okay kind of going with the fee history as kind of a default, and capping the number of blocks that it returns the history for to some small number around, you know, like 8 or 10-ish? I see a +1 from Besu. Any objections?
Nope.
Okay. So great. Let's do that. I guess we have the spec in your gist, Zot. Would you be able to open a PR against the JSON-RPC specs, or should somebody else do that?
No, I will add these clarifications to the spec first about the block count.
Yeah.
And yeah, then I can open a PR against.
Okay. Awesome. Thank you very much. Cool. So I think those were all the outstanding JSON-RPC issues. I don't know if anyone is aware of any other. Okay. If not, there's one more thing that came up this week with regards to how we treat EOAs and smart contract accounts, which could, under some very tiny edge cases, have the same private key. I know, Dankrad, you've been researching this and wrote an EIP about it. Do you want to take like a minute or two to kind of explain the problem and what you see as a potential solution? Hopefully you're still on the call.
Sure, yeah. So just a quick overview. I mean, so the problem is simple, like an address collision between an EOA and a contract. And just for everyone who's like less cryptographically inclined, to summarize like how that could happen. I mean, we're talking about someone specifically creating a collision here. So like, in order to do that, like in order for that to happen randomly, that would be super unlikely. Like it's 160 bits, like 2 to the minus 160 is like a super small number. That's not going to happen. We can basically assume that that never happens. But someone can basically use collision finding algorithms to specifically create that. And like to give you an intuition, like it's much easier because you only need to get to the so-called birthday bound, which is like root of the difficulty of the problem essentially. So finding a collision, basically what you do is you generate 2 to the 80 end user accounts, and you simulate the deployment of the contracts 2 to the 80 times, and then an expectation you will find about 1 collision between these. And now you see like that is obviously much easier than trying 2 to the 160 times. Like this very simple description obviously has the problem that you would restore these 2 to the 80 addresses, at least for one of those 2 like lists you generate. But in actual practice, that's not true. So there are algorithms, so-called cycle finding algorithms, that do this without requiring these insane amounts of memory. That basically means there's a problem now. And the reason that's a problem, so think about like Bitcoin mining. Bitcoin mining currently solves a problem of this difficulty about once every year. So Dmitry Kovatovich, one of our cryptographers, estimated this and thinks like finding one of these collisions is basically about as difficult as like 1 year of Bitcoin mining, which costs about $10 billion probably, like developing the hardware plus paying for the electricity and all that. Now, like just remember that these kind of estimates are not like an exact science. So like it could easily be off by a factor of 10 either way. I just want to make clear it's not like completely outlandish to think that this could happen now. Basically, someone could specifically try to prepare this now. And now, why is this a problem? So like basically previously, like we thought about the case where, okay, like what you could do is you like create this collision, and then you don't deploy the contract, but you somehow trick a user into sending funds into it, and then you withdraw it using the EOA key. I mean, that is of course possible, but people don't tend to send large amounts to contracts that aren't deployed yet. So it doesn't seem like a very serious attack vector if you like have to invest several billion into finding that collision. However, like when we started thinking about this last week, suddenly we found that actually, even after deploying the contracts, you can still do that. Right now, we don't have any protection against that. Like it's basically, it was assumed, I guess, when the spec and clients were first built that this never happens. And so you just yeah, you just deploy the contract first, and then like it could be something that looks like completely innocent. Like let's say like craziest example would be something like wrapped ETH or something like that, right? You think it's just a wrapper contract. It does nothing and you can always get your ETH back. Well, that's not true if someone had the end user account key for that contract. But luckily this very bad attack vector, we can just stop by just like making all transactions that that have sender equals an deployed contract invalid. And that basically stops this, yeah, in my opinion, most serious attack vector. And all the other ones, they're still kind of annoying, but they are, at least for the next few years, not really practical attack vectors. And that's basically what this EIP does. I think 3607 has been assigned to it. It basically, I think like we should basically, we might not want to treat it actually as a full upgrade. We might just say, well, we're kind of specifying what some previously unspecified behavior was. And so we say like these transactions become invalid, and then, yeah, this cannot happen. Cool, yeah, that's the summary from my side.
So thanks, Dankrad. I think there's also one thing worth specifying. Oh, and I'll let Micah speak right after this. But one thing worth specifying is this EIP doesn't actually require a hard fork, but only a soft fork, because it's like a tightening of the rules. It doesn't introduce any new features. So, you know, while there might be some value in trying to like time the deployment alongside London because people are forced to update then, this is actually something that can be deployed as a soft fork at any time. Micah?
Yeah, that's good.
I'm just curious, what's the status of extending addresses to full 256 bits is? Like, if that's close, then this feels unnecessary. If that's still like a year off,
No,
then
it's
this
not.
feels much more necessary.
It's at least a year off, would be my estimate.
I mean, we haven't really even got a proper specification of that yet, right?
Yeah, like last I heard,
I definitely wouldn't call it close. I think it's still open field.
There's also something that can be soft forked in and out, assuming, you know, there hasn't been an instance of this before. So it's not really an issue if for some reason we reverted it when we had larger address spaces.
No, that's true.
And as I understand it, it is like a pretty small implementation change, right? Like you're just adding one check when you verify the validity of the transaction.
So the nice thing about this is that in order to, whenever you want to do that check, you must have already loaded this try object, this state object from disk. So you already have it. You have the code hash, and you can immediately check if it equals to the empty code hash. So there's no extra cost really to do this check.
So my proposal for this was, yeah, given that it's like 3 lines in Geth, and you know, it is like a small change, but at the same time, it's not something that's probably going to happen tomorrow. You know, there is still like a pretty high like I guess hash power needed to actually exploit this. And because we've mentioned in the past, we wanted to see London on testnets sooner rather than later. I was wondering if this is something we could add into clients, basically in the mainnet release for London, so that we kind of go to the London testnets with, you know, the fork as it's defined now. I think in the past there's also been some concern about like accepting something the first time it's presenting on all core devs, because, you know, people might watch this meeting a week from now and come up with some objection or whatnot and want to raise that, so that, you know, if assuming like, you know, no one has an issue with it, on the next call we could just say this is something we add to the clients before the mainnet release of London, but that we don't have to delay the testnets because of that. I'm curious what people think about it. Oh, Thomas is against.
Sorry, I'm generally against of dropping anything more to London, even if it's small. So even if we find those collisions, at the moment it's just a question whether there's consistent behavior of all the clients or not. Like just sending the transactions from the contracts is not a problem of itself, right?
No, it is a huge problem because you could steal all the funds. Like say like someone had done that for wrapped Ether. Like just to be clear, I assume it's not been done for wrapped Ether because it's been deployed years ago. But like if someone had premeditated this and deployed that contract with this collision, then now they could use their key and take all the Ether that's right now in that contract and transfer it to their private account.
Okay, so that's what you mean, that it might have been planned, like a long-range attack, right?
Or anyone, yes, or anyone could plan it right now. Like, I mean, we first thought about this like 1 week ago, but someone might have thought about it last year. Not super likely, but there could be someone basically ready to deploy this.
Yeah, it's I think also important to not overestimate the ease of doing this. Like we are talking about 2 to the 80 computing power, which is an insane amount of computing power. And like, yes, it would be medium difficulty if we had ASICs for it, but nobody has ASICs for Ketchak at the moment. So.
Yeah, I mean, I generally agree that it is very unlikely that someone has this right now. On the other hand, someone could start this now that actually there might be worthwhile. Like 1 year ago, probably nobody would have done that. It's just the whole Ethereum network wasn't worth that much, but now it's very different.
I don't know, just like my feeling is that the urgency is nowhere near high enough to even think about doing like modifying London to put something like this in.
So one easy, potentially low friction way to include this would be to get the fixture test ready for this that would demonstrate compliance with it, and then just to get them merged after London is out so that they are already part of whatever comes next. And so by the time that we get to our next hard fork after that, and clients are working on compliance with whatever new versions of the fixture tests are coming out, these are already part of that base and they inherently have to add it in by the time the next fork gets around.
That would be the merge then.
Not necessarily, because we're pushing back the difficulty bomb to December 1st. Assume the merge is not ready December 1st. We're going to need to push back the difficulty bomb again. So that means that would be, like, I guess at the latest, if we don't do it now, we'll do it December 1st, roughly. Martin, you've had your hand up for a while.
Yeah, I think it's important that we, agree on this and that there's consensus that it's something we should have. I don't think we need to tie it to a hard fork. I don't think all the clients need to say, yes, we're going to include it for London. As long as we have this agreement, I think clients can just merge it whenever, wherever, as they see fit, as fits with their release schedule. If someone exploits this, and then they have paid $1 billion for consensus issue on Ethereum, which I think is a nice price. I think it's a decent security. Yeah, so I would just, if we just get agreement, I think we and Guess would probably merge it pretty soon, probably for London, maybe after. Definitely not wait another half year to the next hard fork, but whenever we feel like it. Yeah. Anyone disagrees with that?
So the only thing blocking it from merging it right now are the state tests, because a lot of state tests assume that the sender has some kind of code. So we need to, or I already rewrote the state tests so that they don't do this anymore. So they can be verified with a new change in. And I now have to write some tests basically for the change to verify that a client has this query. And as soon as this is done. The problem is that we have to merge the tests before we merge the updates in the clients. Otherwise, the testing pipelines for the clients will fail.
Just for clarity, if we go with Martin's plan, are we asserting that should someone do this from here on, it's a consensus failure if anyone includes such a transaction and accepts that block, regardless of whether you update your client or not? The right or the canonical fork is the one that does not include such a transaction. Is that correct?
So it will only lead to a consensus failure if it's not the majority mining client like that rejects it. Otherwise, the longest chain would not.
I would.
So, like, let's say Nethermind. Let's say Nethermind implemented this, which has, I think, no miners. And no one else implemented it, and then someone exploited it. Nethermind's canonical chain in this hypothetical chain split, because we're agreeing that is the rule. If you don't update your clients, that's your problem.
They would fall off. So it's I mean, as long as if Geth merges it for London, problem is solved.
Like Nethermind is not mining on mainnet, so there is no chance that this will be included in Nethermind against what Geth believes.
Sure. So I guess maybe what we're saying is Geth goes first, everybody else will follow, and then as soon as Geth implements it, at that point forward, that's the canonical rule set.
Yeah, I think it can be just assumed that this is currently the rule. It just might be buggily implemented on the clients, which means that if Geth follows the change, it doesn't even have to go as a hard fork because it never happened on mainnet, nor we plan it happens. So it can go just like as a soft update, and then just Geth says like, oh, we updated it. And then if we fail to update very quickly, then we took a responsibility on ourselves in Nethermind that we have a split that nobody will follow because Geth will have overwhelming majority. And that's why
I think that's what the EIP means. I think Dankred, it didn't put a rule where at block number X, but I mean it's a retroactive rule. So it's not actually tied to hard fork. There's just a practical aspects of everyone are going to update pretty soon. So it would be neat to get it in for them, but it's not tied. Yeah.
So does anyone disagree with just the nature of this change, that this is what we should do?
No, I'm in favor of the change, just didn't want to have it as like a necessarily tested change for London, because that's what I thought would be quite a big effort on the testing teams. But I'm totally agreed that Geth can go with this change, that we want to go with this change, and we would go with it as fast as possible. Just didn't want to have it officially in London.
Does anyone have a different position than that?
Quick question: did someone verify that this actually never happened? This kind of transaction.
I mean, we can verify that somebody. Oh, go ahead.
I mean, we can just do a full sync with Mary's PR, and then we're done.
Yeah, so I would like that proof that it never happened. It's very unlikely, but.
Sure.
Cool. Okay, so I guess just for the next steps, maybe, so we'll do a full sync, verify this never happened. Assuming that's the case, clients can implement it whenever they want. We agree that's kind of the general, or that's kind of the canonical behavior. My last question would be like, where does this get documented? So if, somebody wants to build a client 1 year from now, if this is not in London, it'll be kind of a weird EIP that's kind of standalone that people need to know is in. So is there so we add it to the yellow paper?
Yeah.
That seems like right thing. Yeah.
Okay, so if we can make sure to add a PR to the yellow paper as well, I think that would be good, just so we don't just forget that this is implemented in clients. Thanks, Marius. Cool. Anything else on that? Okay. So I guess last thing related to London, it seems like we're in a pretty steady spot. I'm curious, when if teams feel like they know when they can have a release that they would be confident for to fork on the testnets. There's like a few outstanding JSON-RPC issues. I'm not sure if they're all kind of must-haves for the testnets. How do people generally feel about that? Yeah.
I think we should not wait with the testnet deployment due to JSON-RPC issues. I mean, JSON-RPC are part of the UX, and yeah, it's just good to continue developing the UX on the actual user-facing network.
Okay. Does anyone disagree with that? In that case, when the clients think they can have a testnet release out, is it a few days, a week, a couple weeks?
Tuesday.
Yeah, I have not talked to Peter about that, but I believe we can do early next week about.
Somewhere next week, not exactly sure the day.
Okay, so if I guess does any client team feel like they could not have a testnet release sometime next week? So next week that'll be basically like June 15th. I guess depending on how much time we want to give people to fork the testnets, we could probably we already have like a blog post ready that explains all that. We just need to fill in the client versions. Does 10 days after kind of the releases are out seem reasonable to people for the testnet fork to happen, the first testnet fork to happen, and then they would be kind of scattered over one per week after that? Okay, +1 from BaseU, 2 +1s from BaseU. And that feels okay from Geth. So let me share my screen here. So I'd basically put this together. Ropsten's a bit tricky to find a fork date because the blocks are so high that if you need like a palindrome block, it's hard to get. But we could probably go with the later one, where if we forked Ropsten on block 104.99.401, that would be a Thursday. So we can either get the Tuesday or the Thursday. Thursday is probably closer to 10 days, whereas Tuesday is probably closer to 8 days. Yeah, that would be June 24th, and then we could have the two other testnets 1 week after each. We mentioned before we didn't want to set a mainnet block for now because we want to see how it goes on the testnet, so we don't have to add that into clients. But would people be okay with kind of having these 3 dates for the testnet? So June 24th, June 30th, and July 7th? And yeah, there's a comment in the chat that none of these scenarios have July 14th on the mainnet. For sure, we probably won't get a mainnet fork 1 week after the last testnet fork. So yeah, it would be later than that. And I have some tentative blocks here, but like those are not final. Depends on what happens on the testnets and whatnot. So yeah.
Yeah, I have a question.
Yeah.
So Ropsten and Gurley are both multi-client testnet, and currently, are there any other clients in Geth that does Rinkeby?
So Nanomind can synchronize Rinkeby, but I'm not sure if people are running actively. We may be running one Rinkeby node just to confirm that it's always fine.
Mm-hmm. Well, at least I know that Rinkeby is, all the sealers are Geth.
we always, during the forks, we always run the Rinkeby node. We fully sync it, and then we go for the fork. So that's for sure happens. But we don't.
No,
run
yeah, I didn't mean that I didn't mean that you were lying. I just meant that all the sealers are guests. So for 1559, it won't be very interesting from a sealing perspective. Yeah, I was just thinking if we just never mind.
So you're saying we should either do it
dApps who do testing on Rinkeby, and so making sure that they don't break something, I think is valuable.
Yeah.
Do you want to add Nethermind node as a sealer to Rinkeby?
Yeah, sure, but we can take that offline.
But I guess, Martin, was your point that if it's only get sealers, we could do Rinkeby earlier or later? Like,
yeah, well, it kind of looks like it was building up in priority. I mean, Robson is the most throwaways. We do that first. And it looked a bit odd to me that we do Gurley and then Rinkeby instead of Rinkeby, or maybe even Robson and Rinkeby at the same time, and then do Gurley, because I kind of thought that Gurley was the more well used and higher, more valuable network. But I don't know.
Yeah, I think that's probably a decent assumption. I guess one of the reasons why maybe I would put it first is because it's most used, we probably want to have more data on it, right? Like we want to see more usage. But you know, it's not a very strong.
I think it's fine as it is.
Okay. Does anyone else have thoughts, comments? If not, we could go for like basically these 3 blocks at the top. I'll post them in the chat and in the Discord. Yeah. Any objections to those? Okay, great. So yeah, I'll make sure to share that, and then I'll follow up with the different client teams next week to see when the releases are out, and when they are, we'll put out a blog post to link everybody to the right releases for every client. And just to make this clear to anyone listening, none of these releases will include a mainnet fork block. So that means that there will be another release to download if you're running only against mainnet. This one won't have the London fork activated. We'll figure that out at a later date once the first testnet has forked. Great. So that's everything I had for London. Was there anything else anybody wanted to bring up? If not, so a few, I think, months now ago, Light Client discussed EIP 3074 on this call, and people wanted to see an audit for it to better understand the security implications. So that's been done, and yeah, the auditing team is on the call with us today. They wanted to give a quick overview of their findings. So yeah, maybe Light Client, do you want to start by just giving a quick recap of what 374 is and the context there, and then we can move to the audit?
Yeah, that would be great. Thanks, Tim. Yeah, so if I could just briefly recap for people who haven't been following us closely and may have forgotten what 3074 does. 3074 introduces 2 new opcodes, auth and auth call. The auth opcode accepts a 3074 signature, and it returns the address that signed the 3074 message. Additionally, there's a new context variable in the current frame of execution that allows the executing contract to then make arbitrary calls as the recovered address. And because the caller opcode is kind of a de facto mechanism for authenticating users in smart contracts, that essentially allows users to delegate control of their accounts to certain smart contracts. So we refer to these contracts as invokers because they're the contracts that are invoking auth and auth call opcodes. And 3074 messages and signatures are domain bound to these invokers. And this helps protect users from replay attacks that might be tried to have their messages replayed on other invokers. And so this basically means that all the security functionality is implemented in the invoker contract, and it's sort of a extension of these like protocol security in that sense. And this presents some interesting security challenges, which is why we've had some of these teams do these audits. We believe that like safe invokers can be written, even if it's a small number of them, and that with wallets having allow lists to avoid social engineering attacks, that 3074 can be safe. Even with these security challenges, I think the 3074 is really important EIP to consider including, because it does allow for many desirable constructions. And a couple of good examples of those are, it allows for generalized transaction batching from EOAs. It allows for sponsored transactions that allow people to pay with tokens other than ETH. You can do social recovery mechanisms for EOAs that can be signed off chain and then only be played on chain whenever the social recovery needs to happen. And you can minimize on-chain accounting for state channels. And these are just the things that, kind of we've thought of and thought that would be useful. But I think that because it's such a flexible primitive, that it does allow for a lot of other things that I think people will come up with in the future. And so because of these unique security challenges, we've been working with the Ethereum Foundation to have the spec audited. And there are two main components that we wanted to focus on. The first was an audit of just the specification itself in general, trying to think through the things that could go wrong, the security concerns that arise just from the spec. And that has been completed by least authority, and I'll have them share their findings in just a minute. The other component that was really important to audit was there is a small part of 3074 that creates a breaking change for mainnet contracts. And we really wanted to have this auditing firm DW look into this and see how our mainnet contracts going to react if this change is included. And I want to stress that this breaking change of 3074 is something that's optional to 3074. It does provide the nice functionality of allowing users to send 3074 transactions themselves without relying on some sort of sponsor system. But 3074 without this change does not present breaking changes. And I think it's still incredibly useful to have because it does allow for all of these transaction batching sponsored transaction mechanisms. So just keep that in mind as they're discussing their findings. So if there aren't any questions on 3074 specifically, I can have the least authority team talk about their findings in their audit. Okay, yeah, if least authority, you guys want to go ahead and share?
Yeah, great. Yeah, thanks, Light Client, and thanks for the opportunity to have us work on this. It was a nice experience with the Quilt team. You're all very helpful, and we had a good month talking back and forth about security around this. This is a bit of an interesting audit since it has a lot of potential things that can go wrong. From the surface level, this looks like opening up an account to the entire possible world of smart contracts and leaving yourself vulnerable to any random execution. So just to quickly go over our structure and what we looked into, we looked at current breaking changes. As you had mentioned, you have the DoBob team working on checking the message.sender equaling tx.origin assumption for the frame of execution, and the use cases for that being used against flash loan entries. We looked at the signed data security, what is actually being signed, the type prefix, the importance of including the invoker domain and why that's necessary, and the address manipulation possibilities, social engineering attacks on that, incomplete fields maybe in the commit. We looked at, are there enough fields in the signed data to assume that this is reasonable? Went further into some replay protection, looked at human readability of the signatures, and decided that this was a concern for the wallets. We looked at the implementation security of invokers, trying to reason about if it's possible to create such a trusted and important piece of contract code. We kind of did some brainstorming on all the ways that invokers can go wrong. We kind of made a list of potentially bad invokers and how easy it is for an invoker to do the wrong thing, which again stresses the importance of creating correct invokers and really spending time to make sure that these pieces of code are doing what they're supposed to be doing, and you'll see that stressed throughout our findings in our report. We think a little bit about the permanent authorization aspect of this, where you are signing your account to a piece of code, and this piece of code will have that signature potentially forever. This is comparable to infinite approvals. I think that that's kind of a good way to sort of think about these invokers and compare and contrast to that situation. Infinite approval can be unapproved, but an infinite approval is still infinite, and the damage is going to be done if it's taken advantage of. We look at wallet implementation security because this is particularly important, since wallets will be in charge of securing these invokers, or making sure that signers, users are signing the correct invokers. And this idea of allow listing and creating a set of invokers that the community and wallet implementers consider to be safe. We find that very important. We looked a bit into the relationships, the self-sponsoring case, and the meta-transaction sponsee case, sponsor-sponsee relationship, and any potential pitfalls that may create, distributed network concerns similar to a gas station network and those areas. And we have our general, conclusion that I think is similar to some of the community members. We independently came to the conclusion that an invoker is a sensitive piece of tooling, and it's going to require a lot of care. But if the right implementation is created, if they are perhaps simple enough, if they are verifiable, if they can be formally verified, if we are confident in their correctness, then these things should be able to make their way into a hard-coded list inside of wallets. And you can sort of view these more as an extension of your wallet than giving total access to all of the contracts that you may be interacting with. And I think it was Dan Finley on the Ethereum Magicians forum made a pretty cool post about how you can sort of view an invoker contract as giving specific access. It's giving more functionality to your EOA if done correctly. And this can bring about some positive changes in the current way that we are doing both meta transactions and infinite approvals. If we can bring them to a central point, then we can have more confidence in correctness. That might bring up concerns about central points of failure. The attack surface or the consequences might be more drastic if a single invoker fails and it's attached to a lot of accounts. However, it's also a positive if you are able to trust that source is valid. You don't have to rely on every application implementing something like infinite approvals correctly. So in general, we think that this, if done correctly, if taken time, and if the right use cases are implemented, and wallets implement only the right use cases, that this has some net positives for security. And yeah, that's, I think, our final conclusion.
Thanks for sharing that, Nathan. I don't know if anyone has any specific questions for Nathan, or I think Raya from Lisa Thori is also here, one of the other auditors. But we also have the DDoB team here to discuss their findings. So I'm not sure if it makes more sense to just go ahead and have them discuss, and at the end have questions for both, or if people have burning questions right now.
So I have a question. So basically, your solution to the social engineering issue is the invoker whitelist. Is it correct? In the wallets.
Correct. Yeah. The whitelist is very important. And so I think that is the point, that that allow list might reduce some of these phishing attempts that could be spread across multiple applications.
Okay, and how are we going to call that whitelist? Ethereum banking charter?
That's a good question. So that, I believe, would require some effort between the wallets. And yeah, I think that's a good question. It's important that consensus is achieved. And I think that it's it's a very sensitive piece of code that needs to be done and implemented and white allow listed correctly, right? So that is a good question.
I actually don't think that it's something that has to have consensus. Yeah, I don't think there needs to be necessarily consensus across wallets. It's something that as a wallet, you can say, I'm going to allow this invoker, not that invoker, and then you can tell it to advertise this to your users as this functionality. And you say, look, this wallet can do these sorts of batch transactions because we've done the work to make this invoker or trust this invoker. And that other wallet, they have more features, but they're trusting an invoker that's insecure. And it's something that wallets can decide on their own time.
But in practice, you can get convergence here as people try to avoid blame for, like leaving the approved set, and now you've got a relatively stable equilibrium of, rent seekers. So it's not a great look.
But yeah, you obviously trust the wallet provider with your private key. So if you also trust them to tell you which ones of these contracts are safe to interact with, I don't think that's a big change.
There are cold wallets too.
Martin. Sorry, what was that?
There are cold wallets too, which you do not trust with your private key 24/7. Basically, you have to issue the transaction to do something. Now, with the new mechanic, it can be done for you at any time, forever. So it seems like the recreation of the banking system, basically.
That's just a choice of your code wallet, though.
And that's it.
But you can still use, if you're a technical user, you can make this kind of signature with your cold wallet, or you can choose not to do this kind of signature, right?
Yeah, it's totally opt-in. So if you don't want to use 3074 wallets, you definitely don't have to. There's no automatic anything here.
Yeah, I think it's really best to think of these as like opt-in extensions to wallets, and there will be some standardizations. So like ERC, where basically there's probably one specific implementation for a simple bundling invoke or something, just so it's easier for kind of wallets to kind of maybe expose an API that tells the website if it supports the bundling or whatever. But it's always just like opt-in functionality extensions. That's all it is, really.
We only have 15 minutes left. I also want DDoG to share their findings and have a chance to answer questions. So Giannis, if you want to go ahead.
Sure. So just to set up the context again, we just did the analysis on existing contracts, like the impact of 3074, actually the optional part of 3074 on existing contracts. And the biggest impact, to refresh everyone's memory, is that TX origin equals message sender is no longer a reliable distinguisher of EOAs. So anyone can impersonate message sender. So that's the biggest threat, because this is being used in practice. And we tried to quantify how much it's used in practice and to also inspect both prominent and randomly sampled code and see what the expected impact might be for existing contracts again. So there are lots of details in the report, so I do invite you to have at least a quick look at it. There were lots of automated analysis, both at the syntactic level and the bytecode level, and semantic automated analysis, and then extensive human inspection of pretty well-known protocols. Bottom line, certainly it affects a lot of code. I think that doesn't come as a surprise. Probably it affects around, we sampled around 1.8% of actively transacting contracts right now have some kind of check that combines TX origin and message sender. Now, does that mean 1.8% of the contracts are actually affected? Actually, probably not. In most of those contracts, there are comments from programmers that say, just to be extra safe, or we know that this can be front run, but why not check for EOAs? Some people certainly are not aware that there are issues already, regardless of 3074. Now, what are these issues? With MEV kind of deals, anyone colluding with a miner can actually exploit contracts exactly the same way. So is this code already vulnerable? It depends on where you think MEV attacks are going to go in the future. And I'm not sure if people have a formed opinion on that already, or they'd like me to elaborate on that. But let me get back to the main story. There is a significant impact. We actually think that such code is already kind of half broken, that it's not going to stay safe for much longer. We think that the kind of MEV attacks we're seeing, they're becoming very sophisticated. They will soon be proactive. So 3074 is not actually going to break a lot of code badly, not any more than code would be broken anyway. So that's our subjective opinion. At the same time, we tried in the report to very clearly separate subjective opinion from objective fact. So there are measurements that are objective fact, and subjectively we assess that the risk is not that much greater than MEV. So I can't fully keep up with chat questions. Let me try to sample a few. How would the MEV attack work? So current MEV attacks, they wait for a transaction and then they sandwich it. They wait for a Uniswap swap, for instance, and then they sandwich it. Future MEV attacks could very likely have combined some analysis of vulnerable code that checks TX origin equals message sender. So it can, right now it can only be called by an EOA. And the moment they find such code and they find a vector to exploit it, they issue atomically the exploit transaction first, like they borrow from the miner, they tilt a pool, and then the attack transaction. They make the victim contract lose money by calling the code that has that message sender equals TX origin. So that would be a proactive MEV attack that we think there will be coming within the next few months. MEV attacks have become very sophisticated already. So I think I gave a quick summary. Maybe it was too quick, and maybe I can go over specific topics if people have specific questions. Is there something that you'd like me to elaborate on, or should I go through the chat and try to read questions linearly?
You can ignore chat, I think, just discussion mostly.
So just to add, we did sample a few protocols. We did sample some of the most prominent protocols, inspected the code. Most of the uses of the guard, comparisons of TX origin and message sender, are for flash loan protection. There are other uses, like for instance, for pricing. There are services that give away their services for free to EOAs, but they don't want to give away everything to a contract because a contract can aggregate lots of customers. So that's one concern. There was also a pattern of avoiding griefing attacks, like making sure that nobody can turn down receipt of ETH because they are an EOA. But all of those are secondary patterns. The primary pattern by far has been flash loan protection, price manipulation protection. That's the primary reason why people check that whoever called a function is an EOA and not a contract. Reentrancy was a major concern. We found zero evidence of use of reentrancy. Maybe one contract, maybe GSN actually becomes reentrant if that guard is removed. That was the only instance we found in both automated analysis and manual analysis.
Thanks, Yanis. That was, yeah, you guys did a great job on the analysis. Does anybody have any further questions for least authority or DDoB on their audits?
I think you shared a link to the full audit by DDoB on the issue from here for the call, the first comment. So if people want to read the whole thing, it's available there. And then the least authority one, I believe, will be published shortly. Is that right?
Yeah.
Cool.
Yeah, I don't have any specific questions. I just want to say I think it was a nice approach that was done here, where one approach being just a kind of theoretical thinking about it and modeling it, and the other being more practical hands-on contract static analysis. I've been skeptical about it, and yeah, I can't really stop it anymore. So I guess I no longer object to it if we have done 2 security reviews, and both are kind of positive against it, towards it.
So I'm of course in favor of kind of bringing this to mainnet, but I also think it is dangerous to kind of just do this by attrition. So I would be hesitant to kind of go ahead with changes, even if there's no kind of very specific objection, but if it's still kind of, if people are still generally concerned on some level. So I'm just wondering what the best kind of path forward here then is. Would, like, for example, Martin, I'm not sure, of course, Martin, you were only one of the people kind of concerned about it, but I think one of the most prominent ones. So like, would you, for example, be willing to maybe sit down with us sometime, try and really kind of hash it out and see if kind of we can find any specific concerns, or if we maybe can, I don't know, alleviate some of your concerns, or I don't know. I'm just kind of very hesitant to just kind of, again, to just basically go ahead with something because we tried often enough to make people just not want to reject it, like just giving up on the objections, kind of, if that makes sense.
It's a bit late on the call now, but yeah, I mean, we're going to talk about it on future calls, right? Because now we've passed the security phase, the security reviews that we said we were going to do. And I guess at some future call, we'll discuss when or if to include it, if or when.
Sounds good.
Let's postpone the discussion till then.
Makes sense.
Yeah, and at least give, weeks, if not maybe a small number of months, for people to actually read the reports and comment on them and whatnot. Cool.
So I don't know if they're like, what is a good path forward for 3074 from here, and like what is a good timeline to again discuss potentially scheduling, because I think there is quite a bit of value in having a reasonable amount of lead time, because these invokers, if this does go to mainnet, these invokers need to be developed and audited thoroughly. So it's not critical, but the sooner that we could say this is scheduled, the sooner we can start building and auditing things, and that means the sooner the users can utilize them. So I don't know if we want to plan for, maybe like 1 month time.
Yeah, I think maybe like taking a step back beyond this EAP, once London is kind of out and whatnot, possibly in around 1 month or so, we should have like the mainnet releases out, and at that point we're kind of just waiting. I think there's like the meta question of like, okay, what are we doing next in general after London? Will we have like Shanghai before? Are we going to try and have the merge, and what's needed there? So at least to me, it feels like that's kind of the thing that needs to get resolved. Like we might, like if we think we are going to have like another fork on the execution layer this fall before there's a merge, then we're going to need to start planning that one, and then it would make sense to obviously consider 3074. If we think, on the other hand, like we might actually not have a fork before the merge, and have the merge first, then I feel like it kind of pushes back those discussions. To me, that feels like the biggest like decision point.
Okay, yeah. I mean, these things are things we can discuss in future meetings.
Yeah.
I just want to say like one last thing on 3074. I think that I've had the opportunity to talk to a lot of prominent developers and teams at the application layer who aren't generally represented in this call, and there's exceptional interest in the EAP on their side. And I can help if people are unsure of like who wants to do it and how are they going to use it. I can happily connect people with prominent teams to see like why they want it and how they're going to use it.
So I just wanted to share like my experience with talking with application developers and make sure that their voices are heard on all core devs regarding the EAP.
Yeah, I think that's helpful, yeah, to have that context, because we are sometimes pretty removed from like the end users and how they will use this, and I agree there's been like some, like there's been a lot of enthusiasm by app developers for this. Ansgar asks in the chat, what are the latest chances for a merge this year? With 3 minutes left, I'm not sure we can speculate on that. Marius, you have your hand up?
Yeah. So I don't think we should speculate on merge times, and also I don't think we should take the application land into account in this decision. I think this should be a decision that we make about the security, and if it's secure, if it breaks stuff, and this should not be driven by applications wanting to spend less gas or something.
No,
So
I
think
100% agree. More, it's just a motivation for people to try and figure that answer out sooner than later. You know, if there is no interest in the EAP, then maybe people don't look at it, but I'm just trying to convey that there is a lot of interest, and I would like us to figure out, is it secure? You know, we did these audits, and there's a lot of text now to determine for core developers to determine on their own. And so that's really I don't want to push something through that's insecure or leaves things in a bad place.
My suggestion would be to come with a better answer to the social engineering issue than Ethereum banking charter.
With the Ethereum banking charter is not an answer. I'm not sure where you're getting this from. This is something that wallets will decide. It doesn't have to be consensus among wallets. You can think of it like an additional module on a wallet, and you might choose to use one wallet over another because of functionality. And so this isn't something, there's no charter, there's no, community that has to say, this is what we think is the best, and here's like a voting process. No, it's just, I'm going to use this wallet because it has these functionality, and I trust that it's going to do it safely. And if it doesn't, then people won't use that wallet. That's the most important thing wallets have, is the trust of their users.
Yeah, we're kind of at time, but clearly, yeah, we're going to need more discussions about this in the future. There's two announcements that people wanted to make before we cut off. So one, I see Ronan, you're on this call, and you posted in the chat that Gordy seems to have issues. I don't know if you want to like take a minute to just kind of explain that. I don't know if you have a mic. Oh, Lucas, you have your hands up. I don't know if it's about the same thing.
Yes, we are syncing our node to produce a correct block. I think it should not block it, I hope.
Okay, awesome. And then lastly, Pooja, you had, I think the cat herders are working with Nethermine on a survey. Do you want to take a minute to just kind of walk through that?
Yeah, sure. Thank you, Jim. Ethereum cat herders, in association with Nethermine team, is conducting a survey on Ethereum blockchain users and developers research to better understand the future requirement of client developers in terms of tools and documentation. We thank everyone who already have responded, and this list includes ETH stakers, community, the developers and researchers, and more. If you haven't done it already, consider responding to the survey. If you are anyone who is running Ethereum 1.0 node, 2.0 validator node, and otherwise contributing to blockchain. It also includes hobbies, minor wallets, and on-chain projects, because this survey is going to help us create a better infrastructure for the Ethereum ecosystem. We will be sharing the responses received in a form of report in the month of July. The survey link can be found in the All Core Dev Meeting 115 agenda. It's there, and also at the Cat Herders Discord. Responses are accepted till June 30th midnight EST. Consider responding. We need your feedback to let everyone know what is needed in the system to improve it. Thank you very much.
Cool. Anything else anybody wanted to bring up in less than a minute? If not, well, thank you, everyone. Yeah, see you all on the next call.
Thank you, Tim.
Wow.
Thank you. Bye.
Cheers. We'll be on Discord for a little bit if anyone else wants to chat.
Thanks. Bye.
Bye.